3 seats left. So cool. Well, let's go ahead and get started. So this is going to be a hands-on session about building agents with LLM tool use and knowledge graphs. Definitely open up the slides. We're going to be kind of a mix of slides and hands-on sessions. There's roughly like 3 modules with different hands-on sessions for each of these. Cool. I'll wait 1 more minute for folks to grab the slides. I will say there in a minute, I'm going to show a GitHub repo. The easiest way to do the hands-on session is to sign into GitHub and use what's called a GitHub code space. We'll look at that in a minute, but you do need a free GitHub account. So hopefully everyone has that. If not, you can sign up for a free GitHub account really quick. It's pretty easy. Cool. So this is like a really fun time to be working in graphs. I've been working with graphs for, I don't know, 12-ish years, maybe a little more. The company I work for now is called Hypermode. We'll talk about what that is in a minute, but I spent 8-9 years working at Neo4j. Anyone using Neo4j? Heard of Neo4j? Yeah, cool.
Trying to one day.
And it's interesting right now, right? Like I feel like there's this renewed interest in graphs in general and knowledge graphs specifically because of this like generative AI boom. So this is like a fun time to sort of, I think, reevaluate a lot of the graph tooling that's out there, kind of in the light of these AI workflows, and see kind of with that in mind, like are there new use cases and new tooling that that makes sense. So this session, we have an hour and a half. And there's roughly 3 sections to this. The goal is all about building agents, and we'll talk about what that is, why knowledge graphs are interesting, how LLMs fit into this. But these are roughly the 3 sections. So we're going to spend a bit of time on knowledge graphs. We're going to take a look at LLM tool use specifically, and then take a look at how Model Context Protocol, or MCP, sort of allows us to share tools and help us with building agents. So if you want the TLDR and want to just like skip to the hands-on getting in the repo, this is the repo, hype.foo/hyper-news will take you to the GitHub repo. And then you can clone it. I really recommend though for this workshop to click on the green code button and then go to create code space. This will give you like a containerized development environment all in your browser, so you don't have to worry about setting up dependencies, and there's some helper scripts in there for moving things around. So we'll come back into this in a minute, but that's where we're going. So I work for this company called Hypermode. We are really like an open source company that is focusing on giving you all of the tooling that you need to put AI into production. That's sort of the high level, but really our goal is to build these open source tools to enable developers to build AI native applications, AI agents, things like that. Our core open source portfolio is Modus, which is a serverless agent framework. We'll talk about that in a minute. And the Dgraph graph database. Anyone using Dgraph or heard of Dgraph? Curious. Yeah, a few folks. Cool. Yeah, so Dgraph has been around for a while. Hypermode, we've been a company for a couple of years. We acquired Dgraph and are sort of building knowledge graph and AI tooling on top of that. And then, so that's our open source portfolio, and you can use these tools to build AI agents, deploy them wherever you want. But then, of course, Hypermode has a cloud hosting platform, and we aim for that to be the best experience using these open source tools. So we have service for managing those, and then also do things like model hosting, which we'll use today. So if we think of agents, kind of like the core capabilities of an agent, you sort of categorize these as reasoning, coordination, memory, and knowledge. So reasoning is all about the LLM, right? These models that you can think of as like the central nervous system, right? And then there's some orchestration and memory layer at kind of this app layer, where we sort of need to think about how we are handling, say, like how an agent can act on its environment, memory, like how, based on like my interactions with the agent. Are there any more seats? Folks, raise your hands if there's a seat next to you. There's a couple seats back there if you guys wanna grab one. Raise your hand again. It's open seats, cool. And then the other piece of this is knowledge, right? And so like one way to think about knowledge is this is truth that the LLM, the model, was not trained on, either because this is private data that's proprietary to our enterprise, or because it is new data that didn't exist when the model was trained, this sort of thing. So these are sort of the rough categories. But if you break that out even further and look at the tooling that you need to build an agentic app and put that in production, there's the orchestration things we talked about, being able to work with models, evals, model tracing, all these sorts of things. And so the Hypermode platform, our goal is to put all these things together so that everything is there for you to put AI in production. And on the far right, that maps to the open source tooling that we have. Modus, our AI agent framework, handles a lot of these things. And then on the knowledge graph layer, there's Dgraph, which serves as the graph database for our knowledge. And then Modus Graph, which is an embedded version of Dgraph that lives inside a Modus application. And that's more for managing memory, so interactions with our agent. So going back to the three modules that we're going to touch on today, there's knowledge graphs. These you can think of as providing context for LLMs is a good way to summarize that. There's LLM tool use, which we'll talk about a lot. And tool use is really all about a way to enable models to understand and interact with their environment. And then model context protocol, which is really this protocol for publishing tools for models. Cool. So let's jump in to a little hands-on exercise and get our development environment set up. So like I said, the easiest way is to sign into your GitHub account, go to this GitHub repo, go to hype.foo/hyper.news, click on the green code button and choose create code space on main. And that's going to give you this in-browser development environment that has like text editor, terminal, and it's going to set up everything that we need to go through the workshop. So we'll pause here for a minute to give folks a chance to do that. And I would recommend maybe like having the slides up in one tab and this development environment in the other. I'm going to go through this too. So here's my repo. And I'm going to click on new code space. And this is going to take a minute. But eventually you'll see this VS Code like environment come to life. And so the agent that we're going to build today is going to interact with news articles. So there's some scripts in here that we're going to use to load data into a Dgraph instance, and then we're going to build a Modus app that's going to expose tools to interact with our Dgraph instance, and then we're going to publish that using an MCP server, where we're going. Let me zoom in a bit. So if you see something like this, then you should go. There's kind of a post load script that runs. How many people are at this stage so far? Okay, cool. Any questions while we're pausing here for just a minute? Yeah.
the connection strings, is asking for like .env connection strings.
Yeah, we'll get to that. Any others? Cool.
You need to sign up for the hypermode account.
Yeah,
Button that says sign up here.
yeah, sure. Yeah, it's the top right. There's a login there, but we'll get to that in a minute. For now, if you see sort of this, not that one, this one. You see this sort of environment, you're in a good shape. Cool. So let's talk about graphs. So in this section, we're going to talk a bit about Dgraph, some interesting characteristics of Dgraph, and then for the hands-on section, we're going to launch a Dgraph instance on Hypermode. There's a free tier on Hypermode. There's a Docker script in the repo. I wouldn't recommend that just because I have it set up to work with Hypermode graph. So if you want to follow along, that's kind of the easiest way. We're going to load some sample data and then write some DQL queries, which is the Dgraph query language. So we're going to operate under the assumption that a knowledge graph is an instance of a property graph, and this is it's like our constraint for today. So just bear with me on that. We can talk about whether or not you agree with that later on, but this is a helpful constraint for our workshop today. And so a property graph, how many people are familiar with the term property graph? Have used a property graph? Cool. So property graph model consists of nodes. Nodes have one or more labels that define the type of the thing. We have relationships that connect nodes, and we can store arbitrary key value pair properties on nodes and relationships. I think one fundamental important piece of why I think it is acceptable to say that a property graph, an instance of a property graph is a knowledge graph, is that we can sort of encode semantic meaning in our data model. So we can sort of imply our schema from our ontology onto this. So one important aspect of that, for example, is that we have a canonical representation of each thing. So this graph, this comes from some conference I was at a few months ago, right? So there's a will node. I use my pointer so I don't get away from the microphone for folks online, but here's the will node. And in my data, the next time I see the will node, I don't create a duplicate. I create a relationship that is connected to this node. So I have one canonical representation of each thing. So whether that's a person, a topic, and so on. So if we apply this idea of modeling a property graph to our news data, so here's a news article. This comes from the New York Times. If we look at this, what are the components? Well, there's some text, there's an author, there's people that are mentioned, organizations mentioned, there's images. So we kind of apply this graph data modeling process to this. Here would be a reasonable way to represent this article. Well, we have an article node. The article has a URL, some unique identifier, the date it was published, and then we have an author of the article. We have topics, we have organizations like companies that are mentioned, people that are mentioned in this. We have the image, which we can model as a node. We have geographic regions or geographic areas like cities, countries that are mentioned in this article. Those have a geometry associated with them. And then here we have chunks. So which represent text, like the text of the article. And there are lots of different ways to model chunks, this unstructured data in a graph. One way to do that would be say, okay, each paragraph is going to be a chunk. And then we can store embeddings, right? So we can take this text and we can convert it to a vector and then do things like similarity search and these sorts of things. How many people are familiar with embeddings or have done a vector search? Yeah, cool. Well, lots of folks. So the idea here is we take the text, we pass it to an embedding model, we get back a vector, and we store that vector as a property on the chunk node, and then we can do vector search. When we have a query, we can find the chunk and then start to traverse through the graph. And that's that's kind of the basic idea of this idea of graph RAG. And people are familiar with the term graph RAG? A few folks. So, so RAG is retrieval augmented generation, this idea that we want to find the most relevant data to pass to the LLM when we, along with our prompt, so that the LLM is more informed of what it's doing. What's one way to put it. And so the typical approach to do that is we do vector search with embeddings, find the pieces of our document that are most relevant based on the query. GraphRag kind of starts there and uses that as an entry point. So we might start doing vector search on one of our chunk nodes and then traverse through the graph to find all of the relevant context to pass to our model rather than just this like unstructured data. So we can pass who is mentioned in the article, their other articles, we have other more enriched information about them. But there's nothing I think like super special about embeddings when we're talking about this concept of graph RAG. It's really just another entry point into our graph. So one way to kind of break this up is the idea of a lexical graph, which is based on our unstructured data, the way that we've chunked the data, created embeddings on each node. But then we also have, say, like our domain graph, right? So this is going to depend on what type of data we're looking at. Here we're looking at news articles, so that's our domain. We can also have a geospatial graph where a geospatial index is the entry point to this piece of the graph, right? We have areas that have like polygon representations, we have point geometries. We can see where those geometries intersect. Maybe I'm interested in news near me, that sort of thing. That's my entry point, and then I can traverse the graph to find more relevant context. We can apply this to images as well. We can generate embeddings for images or embeddings of descriptions of images to make this sort of like a multimodal graph RAG. Actually, Amy and David Hughes are doing a session on this tomorrow, multimodal graph RAG. If that's interesting, check that out. Okay, so that's enough of me rambling about Dgraph for a few minutes. Let's go ahead and spin up our Dgraph instance. So we're going to go to hypermode.com, and there's a login button, I think in the upright. We'll take a look at it in a minute. And you can sign in either with your GitHub account or Google, and then you'll be prompted to create your graph, give it a name, and then that will provision a hosted Dgraph instance for you. So let's see what that looks like. And here, I'll take a look at the signed out version. If I go to hypermode.com, you'll see this login button here. And that's how you want to sign in to create an account. Okay, I have this open here. So I'm already signed in. Let me zoom in a bit. There we go. Cool. So
Is there any other option apart from using a GitHub account?
no, whatever's easiest for you.
I can't just put an email or any other name.
Not currently either. Yeah, the only options are GitHub or Google. So hopefully one of those works for you. And if you're following along with the GitHub code space, that hopefully should work. The reason we prioritize GitHub is because lots of folks are deploying applications published through GitHub. So that's I think kind of the most common way is to connect GitHub to your deployment platform. So let's create a new graph here. Let's call it Hyper News graph. And this is going to create a free instance. That one didn't work. Cool. Well, I created some instances earlier. What we want to do next, and kind of the goal here is to, once you've provisioned your graph, you should see this screen with a connection string to your Dgraph instance. We're going to use this in a minute. But let me bring the slides up and we'll pause for a second. Any questions before we move on? Okay, cool. So what we're going to do is take that connection string for our graph, and we're going to go back into our code space environment, and there's a .env file here for our environment variables. Zoom in a bit more, and I'm going to paste that where it says dgraph connection string. And so this instance is private to you. There's a connection token in there and the URL. Cool. So once we have that, we'll be able to load some sample data and some queries, but let's talk a little bit about Dgraph before we go any further. So a few folks that had heard of Dgraph. Dgraph was originally released in 2017 and was inspired by Spanner at Google. So the D in Dgraph is for distributed, and so that's kind of the optimization that Dgraph makes in its architecture is for sort of scalable in the sense of volume of data. And this is a big trade-off, right? Like building a database, especially a graph database, is an exercise in optimizing for different trade-offs. And other graph databases don't do this, don't have like this concept of sharding or distributing your data across multiple machines built in. Instead, they optimize for how much data can I fit on a single machine, and instead of sort of sharding that, I'll replicate that so I can sort of scale out that way. So anyway, that's kind of the core optimization that Dgraph makes is scalability in the sense of volume of data. Dgraph is really interesting in that it exposes this property graph model, right? So that's how we think of the graph when we query it. But Dgraph uses RDF for data interchange and for defining your schema, this sort of thing, which some folks might think is kind of odd. Like there's usually this sort of separation in thinking of RDF systems and triple stores and Shackle, and then like the property graph, Cipher ecosystem. And Dgraph is kind of a hybrid of those, which is interesting. Dgraph uses a query language called DQL, which we'll talk about in a minute. So DQL was heavily inspired by GraphQL, which we'll talk about kind of the reason for that and the differences there. Coming from the relational world where your smallest unit of record is a row, here the smallest unit of record is a triple, which I think is familiar to a lot of folks. Yeah, and we already talked about use of RDF for data interchange. So 2017 was the first Dgraph public launch. It was an open source project created by some folks from Google, again, optimizing on this idea of distributed. So when we talk about like this mix of property graphs and triples, like how does this work? Well, the property graph model, we already talked about that. We have nodes, they have one or more labels, relationships have a type, a direction, arbitrary key value pair properties. If we look at the sort of triple, more RDF-y way of expressing that, we have subject, predicate, object. Subject is a node. Predicate can be either a relationship or a property. And then the object is either a node or a property value. And so we can sort of build up a property graph with multiple triples. The way that Dgraph does this, and the way sort of Dgraph kind of bridges these two RDF property graph world and like the reason why, which we'll see in a minute here. So if we start off with a property graph to get this into sort of RDFE triple terms in the way that Dgraph does this under the hood, first we need a unique ID for each node. And this maps to an offset and disk in the file store. So we have very fast lookups there. And then we need to go into this like triple RDF representation. So subject, predicate, object. The subject becomes the unique ID for each node. Like I said, the predicate is either a relationship or the name of a property. Then the object is either a unique ID for a node if the predicate is a relationship, or it is a property value if the predicate is a property. And then to optimize for traversals, Dgraph uses this thing called a posting list. So here, if we look at this case, we have the follows predicate for ending in CD. This is Anne. So here's Anne's follows posting list. We collect the IDs, the offsets on disk of all of the nodes connected to Anne. And so because those IDs are just offsets in the file store, that's a really fast traversal, right? I'm essentially just like chasing pointers when I traverse from Anne to any other node that she's connected to. And so this is the way that Dgraph implements sort of very fast traversals. But there's an important thing to note here is that that's a fast lookup in one direction, right? So I can go from Anne to any of the nodes that she's connected to without hitting an index, just follow the offsets on disk. But I can't go from any of the nodes that Anne is connected to, let's say like from June back to Anne, unless I sort of reverse this posting list. And so this is kind of the trade. If you come from the property graph world, like you're with Cypher, especially, the direction of the relationship kind of doesn't matter at query time. You can query each way. In Dgraph, when we're sort of modeling the data, we need to explicitly say, hey, we want to follow this as a reverse relationship. So just something to be aware of there. And then to get to the distributed part, how does Dgraph like shard data across machines? Well, it groups shards by predicate. So you can think of predicate as kind of like a shard. Yeah.
Question. So if you sort of need to know which direction you're querying, how do you handle that if you don't know the direction? Like someone has a connection to something else?
So there's that's a good question. So like in a property graph model, like every relationship has a direction. If you want to treat that as an undirected relationship, then you would create a reverse in the schema language that we use. This is called a directive, but it's basically just adding this reverse directive to the schema, which we'll look at in a minute. That's basically defining that relationship in both directions. Yeah.
Actually, Cypher also had the opportunity that to query either vertically the graph and
Yeah. So exactly. So like in Neo4j, every relationship still has a direction. Like when we store it in the database, there is a direction there, but we have the option at query time to not specify a direction, and then that's essentially treating that relationship as undirected. Yeah. So one difference there is like we don't have to explicitly upfront ahead of time if we're using something like Neo4j. We don't have to explicitly say, hey, this is a reverse or undirected relationship. We can just treat that at query time. That's something that trips folks up a lot coming from like the property graph world to Dgraph, is why I like to mention it. But yeah, good call out. Cool. Any other questions before we start talking about the query language? So Dgraph, like I said, the first public release of Dgraph was in 2017. And in 2016, something kind of interesting in the, call it the graph world, happened, which was Facebook open sourced GraphQL. Anyone familiar with GraphQL or use GraphQL? But yeah, a few folks. So GraphQL is a API query language. It's not a database query language, but it does sort of make this observation that your application data is a graph, allows you to model and query your application data as a graph. And there was a lot of interest, I think, from a lot of the graph vendors at the time, like, hey, is there some application for GraphQL in sort of the graph database and knowledge graph world? And so I think, you know, at Neo4j, I worked on Neo4j's initial GraphQL implementation. Dgraph did something similar, borrowing some inspiration from GraphQL initially, and then sort of adding some functionality to a GraphQL-like query language to make it actually a database query language. And then later on, I also added actual like native GraphQL support, which we're not going to talk about today. So DQL, if you're familiar with GraphQL and you take a look at DQL, it looks very similar to GraphQL because it was very much inspired by GraphQL, and I think
Recorded.
I think the idea was that we want to have a database query language that is friendly for application developers, which is, I think, a large reason for taking so much inspiration from GraphQL. But this is the basic structure of DQL. We start with kind of a root filter here, which we'll get into that in the next slide. So here we're talking about optional query parameters at the top here. And then in the query, we have the query block. And in the query block, we have this kind of like nested structure. So we start off with this root criteria. So a graph traversal, we always have some starting points, right? And typically we might use like an index to look up maybe like a node by name, or maybe this is like a full text search, or like a vector search, geospatial index search, like some way that we're finding the root starting point, which is either a node or a bunch of nodes. And that's this idea of the root query. We can apply like other functions and filters to them here at the root. But then this nested section is the selection set, which is what is expressing our graph traversal. And it's also expressing the pieces of data that I want to return. So here we're saying I want to return the name property from the Indiana Jones node, the initial release date, and then I want to traverse this executive produced by relationship to find who produced it, return their name. So that's how we express traversals in DQL with this sort of nesting. And then you can see what's different from GraphQL. We have this concept of functions in our root criteria here that allows us to express that initial predicate. We have these other functions that we can sort of annotate. GraphQL is something similar called client directives, but they're handled in kind of a different way. And then the response, this is a JSON representation of the response, matches the structure of the query, the selection set. So we're returning exactly the fields that we requested in the selection set in the same sort of nested structure. Okay, cool. So that's an intro to DQL. The next step is to load some sample data into our Dgraph instance, and then we're going to use the Ratel database client, which is like a query workbench for Dgraph. That's to write queries, visualize the results. And we'll look at some examples there. But before we move on to that, any questions on what we've talked about so far? Cool. Well, let's do it. So the first thing we're going to do is go into our code space environment. And I created this make file that has just some helpers for uploading data, moving environment variables around, and this sort of thing. So I'm going to run make upload data. I ran this on this instance already, so I'm not going to run it again. But this will basically take a RDF data set, which we can look at here, and upload that into our instance. And we'll also apply the schema to our graph. So let's talk about those two concepts really quick. So in the Dgraph directory, there's a schema.dql. So we talked about DQL as a query language, but here's how we express our schema. If you're looking at examples from Dgraph, you'll see like the DQL schema examples and GraphQL schema examples, because we can also define a schema with GraphQL types. They're a bit separate, so we're not going to talk about GraphQL today. This is purely the sort of DQL RDFE format of expressing schema. And you can see here, here's an example where we've defined a reverse relationship. So the idea here is these are all of our predicates. So each row is a predicate, and then the type of the predicate, if it's a list of UID, those are the unique identifiers for our nodes. If it's a list of UIDs, that's a relationship predicate. So here is this article geo is a relationship predicate, and we want this to be a reverse relationship. We also declare our indexes, so we have an embedding predicate that is a vector, and we want to create a vector index for that. Similarly, we want to create a geospatial index for our coordinates. And then the sample data comes from the New York Times API. And there's a script in here for fetching data from the New York Times API and converting it to RDF. I took a sample of that in this guy, which it says is too big. Can we open it anyway? Let's see what happens. Yeah, there we go. So if you look at the Python script that I wrote, it kind of follows this approach of sort of taking the type. So in this case, this is a predicate for an article node, and then some unique identifier. And then this, after the colon, this becomes a variable that I can refer to later throughout the rest of this this RDF file, which I can then load in one mutation operation. So this is our node. Our predicate in this case is dgraph.type, which is the way that we represent that property graph mapping, right? We have this dgraph.type predicate. So this is an article node. Title, embedding, value here, which I used, I think the Nomic embedding model. And for relationship predicates, we just refer to that variable that we defined above. So here we're connecting an image to an article. And this is a sample. There's, I don't know, maybe a few hundred articles, like 10,000 nodes overall. Cool. So that's the data we're working with. Next, we're going to open Ratel. So if we go to ratel.hypermode.com, I'll bring the slide up so you can see the URL for that. That's this, ratel.hypermode.com. Ratel is a query workbench for Dgraph, or like a client. Like often we're writing application code and using one of the Dgraph clients that's like Python, Go, JavaScript, like these sorts of things. But it's nice to have a web-based tool to write some queries and visualize your results. So that's nice. So Ratel is one of those. Ratel.hypermode.com is just like a hosted instance that you can connect to a local Dgraph instance or one running anywhere. And the way that we're going to connect to that is if we grab our Dgraph connection string from Hypermode and go to a Ratel here and paste that in where it says Dgraph connection string and then connect. We'll see this screen. I already ran a query, but the simplest query we can run, let me zoom in a bit, is schema and then an open and closing curly brace. And we can see both the JSON representation of that and also the graph representation of us. This is just telling us, here's all the predicates you have, any indexes that are on them, and so on. So let's take a look at a few queries. In the README, so if we go to the GitHub repo, in the Dgraph directory, in that README, there's an introduction to DQL with some example queries that kind of show some basic things we can do with aggregations, filtering, filtering by dates, full text search, geospatial, similarity search, and so on. So I'll go through a few of these. Feel free to like copy and paste those from the README as we go through them. Is probably the easiest way to do that. I think I have most of these here in the history, so I'll just click so you don't have to watch me try to type those. So here's an example of an aggregation. So this is the name of our query. This name doesn't really matter. It's just going to be reflected in the JSON response. But what does matter is how we define our root starting criteria. So we're starting off by finding all nodes that have a certain type, which is article. And this is where that dgraph.type predicate comes in, because really what we're filtering for is all nodes that have this dgraph.type predicate where the value is article. And then here we're using an aggregation function. So rather than this like nested selection set, we're just doing an aggregation function where we're counting the number of UIDs, the number of nodes that we have, and we have 491 article nodes in our database.
Where do we find the queries again?
They're in the GitHub in the README. If you go to the Dgraph directory, in the README, there's this introduction to DQL section. And I just kind of grabbed a few from there. So we can, in addition to defining a root criteria with this type function, we can also use this filter directive to apply additional filters. So we're saying, okay, for every article node, apply this filter where the article.publish date is greater than January 1st, 2025. And then for each article, give me the title and date it was published. But I can also add nested selection set here. So maybe I want to say article dot geo, if there's any geographic areas in here. I think I may have frozen the Wi-Fi there. That's okay, I'll come back to that in a sec. Go. let's reconnect here. It's also helpful if we're dealing with a large data set to be able to use the first function. So let's just return the first 10 that we find. And then for each of these, we'll geo. And so this is going to be for each of these articles, what geographies are mentioned in them. So here's an article, an interview with Keir Starmer's about Europe and Great Britain. Here's one about the Colorado legislature and so on. So we can define this nested traversal structure. We can also use, what are some interesting ones here? Here's an example of this concept of a reverse relationship. So here we're starting from the topic node. So we're just finding the first 10 topics. We get the topic name, and then in our schema, we have this concept of article has a topic, but if I want to go from the topic to the article, I have to have explicitly said I want this as a reverse relationship, and then this adding this tilde here is how we define that reverse relationship traversal. So here is the topic finances, and there's one article with this topic. We can alias this field so it makes a little more sense in our JSON. So here's topic finances, and here's all the articles for this topic.
All right, one more time, where are the queries that we can just paste in to follow along?
Yeah, they're in the README in the GitHub repo.
Yeah.
So here's the main page. If we go to the Dgraph directory,
Okay.
they're in the README. If you scroll down to Introduction to DQL,
Okay.
I'm just grabbing a sample of those ones.
Well, I'm not getting any articles back. I have the one for the first 10 articles and it's.
Were you able to run the make upload data
Yes.
command, and that worked okay? Maybe try running that command again. I noticed with the Wi-Fi, sometimes that times out. So that might be, if you're not getting results, maybe try that, running the make upload data command again. That timed out for you?
Yeah.
Yeah. Yeah, I mean, if you keep getting a timeout because of the Wi-Fi, maybe try it a few times.
Access denied.
Sorry?
Access denied for the.
That's not good. Okay, let's let's take a look at it in a minute. Okay, maybe let's take a look maybe at one more query. What happened we looked at there? We can do full text search if we've defined the index ahead of time, right? So here we're searching for technology AI using the full text index. We get back something that doesn't match exactly. And another entry point is this concept of geospatial queries. So here just using point geometries, we can find any geos within 50 kilometers. I think this is somewhere in New York, and then traverse from there. Yeah, question over here?
Yeah, I was able to use the mutate to add the articles. So if they're getting a problem, then up to.
Oh, okay. Cool. Yeah. So so if you're trying to run the make command and that doesn't work, you can in mutate you can copy the RDF file. There are a couple in there. Did you use the?
From the README on step 5, there was import sample data in Dgraph.
Oh yeah, cool. Right, exactly. That is. We can look at it in. the browser, right? So if the make command timed out for you, here is the a DQL mutation that you can add. So you can copy this, and in Ratel, switch to mutate and paste that in here and run it. That's basically doing something similar to what that make command is doing, just loading those the RDF triples. Yeah, good call out. Thanks. Okay, cool. Well, we've got 40 minutes left. Let's move on to talking about LLM tool use, unless anyone has any other questions about what we've looked at so far with Dgraph. Cool. So yeah, in this section, we're going to talk about sort of what are tools, how we can define them, and then we're going to look at how the open source Modus framework, which is Hypermode's serverless AI agent framework, lets you work with defining tools for your models, and then we're going to run a Modus app. Cool. So I think most folks are familiar with this concept of LLMs, large language models. The basic idea here is we give it a prompt, some magic happens, and we get some output, right? This is kind of the very, very basic building block for building an agent, which has a lot of different definitions, but for our case, we can think of an agent as something that's orchestrating interactions between LLMs, user tasks, application logic, user input, and to accomplish tasks. But if we look at this, there's not a lot of those pieces, right? There's user input, sure, but there's no like application logic, there's no concept of tasks, like this sort of thing. So I think we need a little bit more for our model to build an agent. And Anthropic published this blog post called Building Effective Agents, which had a framework for how you can implement different types of agents and different ways of orchestrating multiple agents and this sort of thing. But they had this very basic observation that they talked about, which is this idea of the augmented LLM. So instead of just giving the LLM a prompt and getting some output, well, we need to also give the model access to external data through retrieval. This is something like RAG, retrieval augmented generation, where I'm going out to some external database to find data that the model wasn't trained on, and providing that in the prompt. And this is often based on the user's query to find the most relevant content. I also need to give the model access to tools, right? We said tools were a way that we enable the model to learn about and interact with its environment. And then this isn't just sort of a one-off, right? Like there's often like a chain of interactions with the user or with another agent in LLM. So we need some concept of memory based on the previous interactions with the model. And really there's cases for knowledge graphs in each one of these steps. Certainly for retrieval, where we talked about this idea of graph RAG, where we may start with an embedding and then traverse through the graph to find the most relevant context. Tools, where we may need to interact and update a knowledge graph based on some curation or something that we've learned in our organization. And then certainly memory, if we think of our conversation, user interactions with an agent, we can sort of extract out what are the things that we're learning there. Again, this curation step, like what are the entities that we're talking about, and that sort of thing. We're going to focus on the tool piece of this for the moment. And at Hypermode, the way that we enable tools for models is with an open source framework called Modus. Modus is we think of it as an agent framework. It's really a serverless API framework that gives you abstractions for working with models and data and tools. So at its core, Modus will take a function. So Modus is written in Go, but we use WebAssembly to enable multiple target languages. So you write a function either in Go, TypeScript-like language, and then that's compiled to WebAssembly in this nice little sandbox environment. I'm curious, how many folks are writing Go or have used Go? Few folks. Okay, cool. What about TypeScript? Is that okay, mostly Python for most folks? Yeah, cool. In other languages that folks are using day to day? C Sharp, Java. Cool. Okay. Yeah. So we're pretty big on Go internally, but that's kind of our default. But what's nice about Modus is because we're using WebAssembly to enable this polyglot, framework for multiple target languages. I think that's one super interesting benefit of using WebAssembly this way. The other is that every invocation in Modus is in this very sandboxed environment, which is memory safe. Anyway, so the basic idea here is you write a function. At build time, this is compiled into WebAssembly, and Modus uses GraphQL. So we inspect all the types that you've defined, the signature of your functions, and stitch that together into one sort of unified GraphQL API. And then at query time, when you invoke a query field that maps to these functions, Modus builds this like execution plan. And I should say also like the important piece here is the abstraction of functions that gives us this generated API. But of course, that's just the starting point. We also want to interact with models and data and other APIs. So we have abstractions for working with those in Modus as well. So here's kind of I don't know, like a high level architecture of Modus. I already mentioned this idea of this WebAssembly sandbox and having multiple target languages, compiling that to WebAssembly. But we also have this concept of host services, which can be interactions with models or connections to other databases. And then the GraphQL execution piece is another interesting piece that is generating our GraphQL schema and sort of handling the networking layer. Curious, anyone using GraphQL day to day? A few folks? Okay, cool. Okay, cool. So let's take a look at how we can use Modus with our Dgraph instance. Specifically, we're going to want to use some models here. So one thing that we provide in Hypermode platform is a model router. So this allows us to generate a single API key and then access open source models that Hypermode hosts, like the Llama models or like Nomic embedding models. But then we can also access OpenAI and Anthropic models with this same API key. So this is really a convenience piece of being able to have all of the pieces together, not have to think about, oh, I have to sign up for OpenAI, get another API key and that sort of thing. So it's nice for getting started. But really the benefit here is once we are developing, it's really, really easy to switch out different models. We don't have to change any code, just a configuration parameter for what model we want to use. So let's go back to Hypermode. And I'm going to go to the model router section. And we can see the different models that are supported. And so this is a mixture of models that are hosted on Hypermode infrastructure, like the open source models, and sort of proxies for the like OpenAI, Anthropic, the paid third-party model providers. But initially there's a free tier, so we can run these for development and testing. So I'm going to click create a new API key. Let's call this KGC workshop API key. Cool. I'm going to copy that and go back to my CodeSpace development environment. And there's a Modus directory. And in Modus, there's a separate .env file. So I'm going to paste this where it says Modus hypermode router token. And then I also need to drop in the connection string for Dgraph. I was trying to write a makefile to handle moving around all of these environment variables from one env file, but couldn't quite get it working, so we're just going to do this manually. So the other thing I'm going to need to do is go back and grab my Dgraph connection string right here. And this is actually going to go in this modus.json file. We'll talk about what this file is in a second. But if I scroll down, I'll see in connections a Dgraph object, and I'll see these little squiggles under connection string, which means it doesn't like this placeholder. I'm going to paste my connection string there. So what is this modus.json file? Well, this is our app manifest. And so in modus.json, we're defining the connections and the models that I want my Modus app to have access to. And also the generated endpoint. Currently, we're generating a graphical endpoint. The models that I'm going to use. So this is a bit of a grab bag of a Modus app. There are a lot of different pieces in here. We have an embedding model. We have GPT-4o Mini. And then we have a couple of different connections. I have a connection to OpenAI. So if I wanted to use my OpenAI key, I could use that. But we also have a connection to Hypermode Router, which has this base URL models.hypermode.host. And so this is a OpenAI compatible API. So I can use this in Modus. I can also use it in other apps. We're going to use it in an MPC server in a moment outside of Modus. But this means that I can run these models, the embedding model and GPT-4o Mini through the Hypermode model router using the API token I just generated, so I don't have to think about a third-party one. And then the connections, these are the APIs or databases that I want to connect to. I have my Dgraph connection where I connected our Hypermode graph instance. And if we take a look at the code, so this is written in Go. So if you're not super familiar with Go, that's okay. You don't have to write anything. We're just going to take a look at this. But we could also write this in assembly script, which is this TypeScript-like language that we can use with WebAssembly. So first of all, we've defined some types and so on. Like I said, this is a bit of a grab bag to show different things that we can do. One is to generate embeddings. So this function, get embeddings for text, takes an array of strings, and this grabs our gnomic embedding model, invokes it, and returns an array of vectors. We also have some Dgraph queries for similarity search. Here you can see we're using the Dgraph client to search for locations given a latitude and longitude. This is similar to the query we're running in Ratel, where we're looking for geographic areas and then traversing from those geos to any articles that mention them, following that reverse relationship. But let's go ahead and run this. So we'll do cd modus, go into the modus directory, and modus dev. And so this is going to take this modus app that's written in here. It's going to compile this to WebAssembly, generate a GraphQL API based on the types that we've defined and the signature of our functions. And then because we're running this locally, we're not locally, we're running this in a container somewhere, it's going to start a query workbench that is going to let us inspect our Modus function using GraphQL. And because we're in this like containerized development environment in the browser, it gives us the this port forwarding option. So if we go in here to ports, it gives us the option to open this sort of through port forwarding magic. But this is the Modus API Explorer. And so this is kind of like a query workbench similar to GraphQL Playground, if you're familiar with GraphQL, but you don't really have to know much about GraphQL to use this. The idea here is that we have the functions that we've defined. So for example, let's delay that. So for example, query articles. This says retrieve articles from the database. Let's grab the first 10 articles. And so here's the GraphQL query that we're running. So we have a query articles endpoint, or a query field rather, and then this nested selection set that then gives us our article data. If we look at the code for this in main.go, we have query articles. This is kind of a simple one that's connecting to Dgraph, running this DQL query, and then returning the results. So nothing super interesting there. But that's the basic idea. API Explorer. Okay, so let's look at one where we're invoking a model. So one thing that is really interesting that I realized about these LLMs is that they're actually pretty good at geocoding. So geocoding is this idea of taking a text description of a place, so something like an address or the name of a city, and getting like a latitude and longitude, or maybe like a polygon representation of that area. And so here's a function that does that. So it's a geocode location. Let's say New York, New York is the location we want to geocode, and we get back latitude and longitude. This I checked earlier is pretty much, I think, somewhere in Manhattan. So if we look at how that is implemented, we go back to code here. So we have this geocode location function, and there's a prompt here. So the prompt for the model is, I need the location for a given location, only respond with valid JSON in this format, and I'm giving it a sample. So here's sort of the sample that I'm giving it, and passing that to the model invocation. And so this allows us to sort of chain together. You can see where we're going with defining tools here, because we also have we have a get news by location, which if we go back to API Explorer, we have query locations that takes a latitude and longitude, right? So if I have latitude, longitude, and we'll say 50 kilometers. Didn't like my selection set there. Let's try that. So here's a location that matches within 50 kilometers of that, Fifth Avenue. Here's a news article about that location. There's a few more about Upper East Side and so on. But it would be nice to say, you know, rather than passing a specific latitude and longitude, if I could pass a description, like show me all of the news for New York. Well, I have these two functions, right? I know one function allows me to go from an address or description of a location to latitude and longitude. And I have another function that takes a latitude and longitude and gives me articles. How do I like chain these together? And this is sort of a great example of where tool use comes in. So what I want to do is define tools. So I want to tell my model for all the functions I have, different ways of querying my news graph. So here's a way that you can go from a text description of a place to latitude and longitude. Here's a function you can go from latitude and longitude to news articles. There are also things in here for vector search and things like that. So what I want to do is define these as tools or as functions and give them to the model so the model can orchestrate the calls to these tools given the user query. And we can do this in Modus. So we can take a look at the code here. We have some other examples of generating structured data, which is quite nice. But here in the generate text with tools function, so here's our prompt. Your helpful assistant who's very knowledgeable about recent news, use your tools to answer the user's question. And then we have a way of defining all of the tools. So essentially, tools are just functions, also called function calling. And it's really important though that we have like a text description of both what the tool is, like what the function does, but then also the other thing the model is going to do is figure out what parameters should I pass to this function call. So we also need text description of what the parameters are. So here are the tools that we want to pass to our model. Query articles. So this is a function that is just going to query articles from the database. The parameter is num, which is the number of articles to return. So that's the first one. We have query topics, which I think was using the full text search to find topics and then find articles connected to those. We have query locations, which finds articles based on latitude and longitude. And then we have our geocode location, which goes from location string to latitude and longitude. And then there's kind of an interactive thing here where it's interesting to note, or I guess important to note, that like the model doesn't actually invoke the tool. So in a minute here, we're going to say something like, give me all the recent news about New York or something like that. And the model is going to figure out the plan. So it's going to look at its tools and say, well, you want New York. I have a function that can give me articles by latitude and longitude. I have this geocode. So I need to like figure out how to chain those together. But then the model, rather than invoking those directly, is just going to send back a message that says, hey, Modus app, I want you to invoke this function. And then it's up to our Modus app to then add that data and call the function or call the model again to invoke the model with our updated data. So we have to have this kind of iterative loop that we've defined here. So let's see how this works. So if we go to generate text with tools, we have a basic prompt here. How about let's start by saying, what can you help me with? And so here, in this case, we're sending that prompt that we saw and this representation of all the tools. So the model is going to inspect the tools that it has and says, hey, I can help you with news updates, location-based news. I can do geocoding. You know, tell me what you want to do. And let's say summarize news about New York City. And so what should happen is the model realizes that first it needs to geocode New York City to a latitude and longitude and call the geocode function. And then it's going to pass that latitude and longitude to the function that's getting news by location. And if we look in the logs for this, which is here, if we scroll through that, we would see that sort of execution plan. We're in sort of verbose mode, so we see all the data that comes back as well. But that's essentially what happened there. So this concept of tool calling, this is like I think a really important sort of basic getting started point for building tools. Yeah.
When the model returns multiple results, how do you rank? Do you use LLM again to rank or?
So, so if I heard you right, you're saying like, let's say the model returns a whole bunch of news articles, for example.
It returns from several news articles about New York City. But not the ranking mechanism, which one?
Yeah. So the question is basically like, what's the, when I fetch articles by location and I get a whole bunch, and then there's that like summarize the news, like how am I determining what, how to rank those and so on. And we're not in this case. If we were doing like a vector search or something like that, we would have a distance score, which we could use to rank those. Or we could use another LLM to say, go through a re-ranking step. Or oftentimes, if you're working on some sort of like workflow pipeline, or maybe you're like generating some step before you feed it to the next one, there's some evaluation step. So those are all like very relevant things that you can do. We're not doing that here. We're just kind of finding everything in the database that matches our query. Yeah.
When I tried to run Modus devs, I got bill-tailed because of a manifest JSON error.
Yeah, I got the same.
Yeah, so that one, if you get the, I think it is probably where we needed to paste in our connection string in the Modus JSON right here. Because there was just a placeholder here. I didn't have a chance to wire that up to the environment variable. So if you don't do that step and copy your Dgraph connection string, paste that in Modus JSON and then try to run it again, hopefully that should work. Yeah.
We have got a valid and expired API keys.
Okay.
While running the Modus attack.
For the model router API key. Okay. Yeah, maybe something going on there. We can take a look at that.
I tried to renew the API key. Or...
Yeah, maybe try to generate a new one and just replace that. Yeah. Cool. Cool. So we have like 10 minutes left. Let me go kind of quickly through the model context protocol section because I think this is interesting, and we'll just kind of skip over the example. So how many folks have heard of MCP, model context protocol? Yeah, a lot of folks. How many people have like built an MCP server? A couple folks. Cool. So model context protocol is, I think, really interesting. There's a lot of discussion about it right now because it takes this concept of tool use that we saw, right? So we wrote this Modus app that maps functions to tools, and then we sort of have to orchestrate this like tooling function calling loop and this sort of thing. But MCP kind of extends that concept, and it's really just a protocol that allows us to sort of share tools, I guess is one way to think of that. So it's often compared to like a USB router, right? So USB is the protocol, and I have all of these different MCP servers that define how to expose tools for interacting with different APIs, different files. I don't have to implement sort of my own bespoke way of defining tools to interact with those services. I can just use their MCP servers using MCP protocol. And my app now gains the ability to learn about and interact with those services and tools as part of its environments. So MCP, this was created by Anthropic originally as just kind of a way of sharing tools internally and exposing tools to Claude. The basic concepts are tools. So we saw how to define tools. These are basically functions that have some like text description that we can pass to the model. So the model is able to figure out when maybe it should invoke that tool and also figure out what parameter to generate to pass that function invocation. There's also resources. So resources are different than tools in that they're more like static data. So for example, a tool might be to update some data in a database. A resource might be the schema for that database. And then the third high-level concept is this idea of prompts. And these are kind of like pre-configured prompts that a user might want to invoke in their interaction with the MCP server. So think of like in Slack, like a slash command or something like that is the idea of a prompt. So we'll skip this, but the code is in the repo. If you want to take a look at a MCP server for our Dgraph instance, if you look at our code in the MCP server directory, this is created using Anthropic's MCP SDK for Python. They have them for lots of different languages that make it like quite easy to build an MCP server. So the tools that we have here are one, get the schema of the database. That just executes this simple schema query. Update the schema of the database, run a query. So in this case, the model is going to be generating the DQL query, run a mutation, so an update to the database. And then there are a couple of parameterized queries here. So one is article similarity search. So this is using Dgraph's vector search to take a natural language query, generate an embedding of it, and then find articles that are closest to that embedding. And then we have a resource that's just some metadata. And so that's it. It's less than 200 lines of code. And we can configure this in different MCP hosts. So the MCP host is like the application that is sort of orchestrating the invocation to the MCP server. So you can think of that as where the orchestrating interactions with the model. And then there's a client that's kind of a one-to-one mapping that's a connection to your server. Claude Desktop, anyone using Claude Desktop or Claude in general? A few folks. This, I think, right now is one of the better MCP hosts or MCP clients. MCP is fairly new, so there are a lot of things evolving there, but Anthropic and Claude is doing a lot to make it really easy to say like query your Dgraph instance with natural language. And what you'll see, I don't know why Claude isn't loading for me here, but what we would be able to do is write a message that's something similar to, analyze the news in this location, or even just exploratory data analysis. So we say, tell me a summary of information in my Dgraph instance. Claude is really good about iterating on query generation based on the schema, seeing when there's an error, iterating to find something that works, trying lots of different things, which is pretty neat to see. But we'll have to look at that another time. If you're interested in that, come by the Hypermode booth downstairs later this week, and we can take a look at that in person. I just want to talk kind of in summary here, like how this ties back to agents and some of the other things we're working on at Hypermode. So going back to this idea of like the core capabilities of agents, reasoning, coordination, memory, knowledge, how that maps to models, apps, and graphs, like the different abstractions that you see in Modus, for example. And if we think of, okay, what are all of the pieces that we need, how that ties to like the goals of the Hypermode platform, to have everything you need to put these into production, how that maps to our open source projects like Modus and Dgraph. And one thing we're working on right now is a layer that sits on top of the infrastructure that we looked at today. So we saw kind of how we can fit these pieces together to build agents with tools, knowledge graphs, prompts, and those sorts of things. But wouldn't it be nice if we had the ability to go from a prompt that defines the tasks that I want to complete, the skills that I want an agent to have, to automatically generating that agent, what MCP connections it has to be able to act on its environment, sort of like interactive way to orchestrate these instead of like waiting for approval for everything. One thing that we've found that's quite useful is when we have like a one-way door operation, we don't want the agent necessarily to do that on its own, rather than like pausing and asking for approval, this concept of an inbox where maybe our multiple agents are interacting together, and at the end of the day, we can go through and say, here's all of the things we're waiting to approve for our agents. So this is something that we're really excited about, that we've been building internally, is Hypermode agents that allow us to go from prompt to running an agent in Hypermode platform, connecting through MCP to these different MCP servers to act on the environment, but then being able to eject to code. So all of the things that we looked at today, that's what's underpinning Hypermode agents. So knowledge graphs, Modus, model router for being able to access and switch out models. So being able to have that sort of like low code builder for running and orchestrating our models, eject to code, run on the Hypermode platform or wherever you're interested in. So we're pretty excited about this. We're launching early access, I think, next week. So if you'd like to get early access, there's a link to the forum. Just submit your email and we will follow up with you on that. Cool. And we're just at about time here. So I'll leave up the QR code here. I'm here all week. We have a booth downstairs. So definitely come by and chat. I have some other coworkers here that I'm seeing here, but definitely, yeah, feel free to reach out. And I'll stick around if folks want to leave, and go ahead and feel free to chat with anyone in here. But thanks so much for coming this afternoon. And sticking it out for an hour and a half, and some things work, some things don't.
Shove it through so that when